So today we're going to talk about section 8.3, which is called product sum identities. If you look on your trig identity sheet from the other day, this is like a bulk of the formulas on this page. So it starts down here with the double angle identities, and then it continues up here. We've got power reducing identities. I actually ended up taking these off of the homework, so you won't have to worry about these power reducing identities. Then we also have these half angle identities, product to sum identities, and then sum to product. So it's a lot. This section is a lot of information. We're going to try to take our time and go through this pretty slowly. I'll try to give you a lot of advice about like how to type in your answers on Hawks. That way you don't have to wonder like, do I need to simplify this anymore? Is Hawks going to accept my answer in this form? That kind of thing.
Sorry, you took off the homework because you didn't know the test.
No. Yeah, so I took power reducing identities will not be on the homework and they will not be on the test. So you don't have to worry about these. You can cross them off if you want to. I'll try to white these out for the formula sheet. So just so they're not even there, you don't have to worry about them. All right, so let's get started. Your homework is going to show you a different way to do this first problem. You can see I changed this second one, but let's just talk about this first one first, and then I'll talk about why did I change that. So your homework is going to show you a different way to do this, but I think the way that I'm going to show you is easier. So just know that if you go to the homework and you click that tutor button, it is going to show you something different. Like it's going to draw a triangle, and to me, that method is more difficult. So it says, use the following information to determine cosine of 2x. All right, so cosine of 2x, that's a double angle, so your angle is being doubled. So you're going to go to your double angle identities right here at the bottom. This one is for cosine of 2x. So we have three options for the formulas that we can use, which is nice because that gives you some flexibility in what do you need to know in order to solve this problem. So we'll decide whenever we get going here whether we want to use this first one, the second one, or the third one. But you can take a look at these. You can see this first one looks really similar to the Pythagorean identity. And then these second two are a little bit different. So these are all acceptable versions of this formula, just written in different forms. All right, so for this first one, it tells us that cosine of x is negative 2/5 and sine of x is negative. The way that your homework is going to start these is they always look and they say, okay, cosine's negative, sine is negative, what quadrant is that in? Now, I am going to use that approach on part B, but for this one in particular, I think we can avoid that by just looking at the formula for cosine of 2x. All right, so let's write down cosine of 2x equals. Now, let's look at what we know. We know what cosine of x is. We know cosine. We don't know anything about sine except for the fact that it's negative. But let's look at our formulas. This says right here that we could use this second formula, which just involves cosine. So if you use the first one or the second one, the first one or the third one, then you have to evaluate sine. You have to figure out what sine of x is. But if we use the middle one, we don't have to worry about sine at all. So let's use this one. So that's 2. I'm going to use x's instead of u's. So 2 cosine squared x minus 1. Now, just to remind you, this is super important. What does cosine squared x mean? Cosine squared x is the same thing as saying cosine x squared. So remember we talked about the other day that we don't write the squared on the end, so we don't write like cosine x squared, because this would be the situation or the scenario where you're squaring the angle. And here we're actually squaring the entire trig value. So we're not just squaring the angle, we're squaring this whole thing. So that's why we write the squared on the cosine instead of on the end. All right, so this is the same thing as saying 2 times cosine x all squared minus 1. We know that cosine x is negative 2 over 5. They told us that in the beginning. So that's going to be 2 times negative 2 over 5 squared minus 1. From here, you can just plug this into your calculator. All right, so let's grab our calculator. Just like I mentioned in the last section, this section, the work in this section is made much easier if you have this calculator. So if you have an extra $20, I would definitely suggest going out and getting this calculator or buying it off Amazon. It's super helpful. It gives us a decimal. Let's make it into a fraction. Just to remind you, the fraction convert button is down here, right above the enter. All right, so convert that to a fraction. That's negative 9 over 5.
Did you square it?
No, I didn't. Thank you for pointing that out. I did not square it. So 2 times negative 2 over 5 squared minus 1. There we go. That's better. That's what I got this morning when I did it. Negative 17 over 25. Negative 17 over 25. All right, so I really like this one. This is definitely something that you're going to see on the test, either 1A or 1B. So we'll just highlight this. Just in case you look at this later, you'll know that that's something that is going to be on the test. This is something I think I could make into a multiple choice question pretty easily. Sometimes it's hard to make these into multiple choice because then I can't see any of your work. But this one wouldn't be too bad. I think I could come up with some good multiple choice solutions for that one. All right, now I did change this second one. So instead of determining cosine of 2x, we're going to determine tangent of 2x. And then I changed this part right here from, I think it was cosine, I changed it to tangent. So the reason that I did that was because this one is harder than the one that I originally had on the notes. And I kept seeing this one pop up on the homework when I was doing like view a similar question. So I wanted to make sure that you guys had seen this one. That way, if you do get this one on that homework, that you're not, thinking, oh my gosh, we didn't do this one with tangent in class. I don't know how to do this. Because you can look at the double angle identity for tangent and see that it's more complicated. So I wanted to change it to that so that we could work through that one together. All right, so it says determine tangent of 2x if you know that sine of x is 1 over square root of 3 and tangent of x is positive. So on this one, if you look at the identity for tangent, you can see the double angle identity for tangent just involves tangents. Now we can rewrite tangent as sine over cosine, but right now we only know sine. So we would have to find cosine to do that. So with that said, there's no like easy way to approach this. We are going to have to use that triangle method where we draw a triangle and use Pythagorean theorem. But first, let's figure out what quadrant this is in. All right, so if sine is positive and tangent is positive, what quadrant are we in? Yeah, quadrant 1. All right, so that's going to be something that you don't have to write on your formula sheet this time because I'm going to give you this unit circle and all this stuff will be filled in. So you can see up here in quadrant 1, sine and tangent are both positive. So you can avoid writing that little table on your formula sheet this time. All right, so we're in quadrant 1, which is good. We don't have to worry about negatives in quadrant 1. Everything's positive. So let's draw a little right triangle, and we're going to refer back to SOHCAHTOA. That was from Unit 1. SOHCAHTOA. All right, so my angle this time is called x. X is my angle. So let's draw a little angle here is x. And sine is opposite over hypotenuse. So opposite side is 1. I'm just using this fraction up here that I was given. So 1 is the opposite, square root of 3 is the hypotenuse. And now we need to find this other side. I'm going to call it B. I would usually call it X, but we've already named this angle X, so I wanted to call it something other than X. So let's use the Pythagorean theorem to find that side. Our whole goal here is to figure out what cosine is because we know that sine over cosine is tangent. So we can use the Pythagorean theorem, which is a squared plus b squared equals c squared. That's going to help us to find that other side. So our first leg is has a length 1. We don't know b, but we know the hypotenuse is square root of 3. All right, so that's 1 squared plus b squared equals square root of 3 squared. 1 squared is 1. Square root of 3 squared, the square cancels with the square root. So that becomes 1 plus b squared equals 3. Move that 1 over. Y'all tell me if I'm going too fast and I need to slow down, because I've done this problem like 4 times today trying to find the easiest way to do it. So I feel like I could do this problem in my sleep now. All right, so b is square root of 2. To get b by itself here, let me zoom in on it so you can see it good. To get b by itself, I am just taking the square root of both sides. So that's where square root of 2 comes from. So I'm kind of, glossing over the stuff from algebra because if you're all here, that means you know how to do algebra. All right, so now we can go back to our little triangle. We can fill in, we know b is square root of 2. All right, so I think just a minute ago I said we could figure out tangent because we know tangent is sine over cosine, but there's actually an easier way to do that. We can use the fact that we know that tangent is opposite over adjacent. So that tells us that tangent of x is opposite over adjacent. So let's see what that's going to be. Opposite is 1, adjacent is square root of 2. So 1 over the square root of 2. All right, so now we know tangent of x. We're sort of, I would say we're about halfway there at this point. I'm running out of room, so I'm going to try to squeeze this in over here, but I may have to go to another sheet of paper. All right, so now let's get back to the beginning. What were we trying to figure out? We were trying to determine tangent of 2x. So let's go back to our double angle sheet, or to our identity sheet, sorry. Our double angle for tangent says tangent of 2u equals tangent. 2 times tangent u over 1 minus tangent squared u. So let's write this formula down. So we have tangent, we'll do x here instead of u, because that was our angle name. So that's 2 times tangent of x over 1 minus tangent squared x. We're pretty much good from here on out. We know all the information we need to know to solve this. We can go ahead and plug in 2 times tangent, we said was 1 over the square root of 2. So that's your numerator.
Would you multiply the top and the bottom?
Multiply like 2 times the numerator, and then denominator stays the same. Like think of it as being like 2 over 1. So multiply numerators, multiply denominators. Does that make sense? All right, now let's do the bottom real quick and then we'll start simplifying. 1 minus tangent squared x. So that's 1 minus tangent squared. So that's 1 over square root of 2 all squared. Now, if you have this calculator, you can just plug this in. If you have a graphing calculator, you're going to have to simplify this by hand because your calculator cannot give you answers in terms of radicals. So, if you want to go ahead and plug it in, if you have this TI-36, you can go ahead and do that now. I'm going to continue working it out by hand. So I'm focusing just on the top right now. I'm going to just cover up this denominator for a second. Just cover that up. Just simplifying the top, 2 times 1 is 2. 1 times square root of 2 is square root of 2. So that's 2 over the square root of 2 in the numerator. All over. Now I'm just focusing on the bottom. Going to cover up the top. All right, so let's see. Squaring this, you got to square the top and square the bottom. So 1 squared is 1. And then square root of 2 squared, the squared cancels out the square root, so that's just 2. So this is going to be 1 minus 1 over 2. One minus 1/2 is just 1/2. So that's 2, whoa, I wrote that wrong, my bad. Let's go over here. 2 over the square root of 2, all divided by 1/2. Then you're going to flip. Keep the top the same. Change the operation to multiplication, flip the bottom fraction. Then multiply tops, multiply bottoms. 2 times 2 is 4. Square root of 2 times 1 is square root of 2. And you're done. Now, if you plug this in your TI-36, the answer looks a little different. It's just the simplified version of this, which is where you have to rationalize the denominator. But your homework will accept it either way. So let's see, if you plugged that in, let me show you what you would get. So 2 over the square root of 2 over 1 minus 1 over square root of 2 all squared. Gives you 2 on the square root of 2, which is the same exact thing as 4 divided by square root of 2. So if you do 4 divided by square root of 2, gives you the same thing. So it's just the rationalized version of that answer. That was a lot of work. I would not put one that long on the test, but you might get lucky and you might get an easy one on the homework, but I just wanted to make sure that if you did get this one, then that you have something to refer back to. That way you're not completely on your own on the homework. So not going to be one that's hard on the test. Definitely may come up on the homework. On the test, it's going to look, the level of difficulty is going to be similar to part A. Okay. Now let's look at number 2. Any questions before I move on? Okay. Let's look at number 2. This one probably takes the longest out of any problem in this section just because it has 3 parts. If you came in late, I do have the notes printed out over here if you want to come grab a copy. You're not interrupting or anything if you come grab a copy. You're fine. All right. Let's look at number 2. Given that tangent x is equal to 14 and sine is negative, find sine of 2x, cosine of 2x, and tangent of 2x. Now, whenever I was working this problem out, I kept getting really weird numbers, and I thought, am I doing something wrong? But then, if you look at the original problem, this is kind of a strange value for tangent, so don't feel like you're doing anything wrong. It's just tangent is kind of a strange value, and they're going to give you something like this on all of your homework problems. Like I did a similar question earlier, and I got like 8 instead of 14. So you're going to get weird numbers here. Don't feel like that means you're doing something wrong. All right, so let's look at what we have going on here. Tangent is positive, sine is negative. All right, so tangent, positive, sine, negative. So can y'all look on your unit circle and tell me which quadrant we're in? 3. Very good, quadrant 3. So we'll just keep that in mind. And that means that the angle X is in quadrant 3. All right, so the angle X is in quadrant 3. All right, so let's look at our formulas for sine of 2x, and then we will see what we need to know. So here's our trig identity sheet. we're looking at our double angle identity for sine. Sine of 2u is equal to 2 times sine of u times cosine of u. So we need to know sine and cosine in order for this to work. So right now, we only know tangent. So that might be a problem. So that's definitely going to be a problem, right? The dip shows you I think it's a pretty creative way to do this, but there's always lots of different ways that you can approach these problems. So let me show you how the book approaches this. Like I said, I thought it was kind of creative. All right, so they say, okay, if you want to know sine and cosine and you're given tangent, because they told us that tangent of x was 14, then they go up here and they use one of these Pythagorean identities, which is going to tell you secant, but we know that secant is just the reciprocal of cosine. So this is going to tell you cosine by using this Pythagorean identity. So let's do that. All right, so we have tangent squared x plus 1 equals secant squared x. Now, at first, when you look at this, you think this doesn't look very helpful, but like I said, this is going to tell us secant, which in turn will tell us cosine. And we need to know sine and cosine in order for us to use this formula for the double angle formula. All right, so let's plug in what we know. Tangent squared, that's going to be 14 squared plus 1 equals secant squared x. 14 squared, let's see what that is. 196. So that's 197 equals secant squared x. So I just skipped right in that middle part so I could save a little bit of room, because you can already tell I'm going to run out of room. All right, so what your book does here is they say, okay, well, to get secant by itself, you're going to take the square root of both sides. All right, so we know that this is really the same thing as just saying secant of x all squared. So we can take the square root of that. That's going to cancel out this squared here with the square root. So that tells us secant x is square root of 197. Now we know that secant is the reciprocal of cosine. So that tells us that cosine of x will just be the reciprocal of this. So if this is square root of 197 over 1, the reciprocal would be 1 over square root of 197. So we have cosine, which was part of what we needed. We needed sine and cosine. Because remember, our double angle formula was 2 sine x cosine x. So we've got half of what we needed. Now we just need to find sine. If you ever have sine and you need to find cosine, or the opposite like we have now, we have cosine, we need to find sine, you're always going to go to that Pythagorean identity. So go to your Pythagorean identities. Sine and cosine right here. So there's the Pythagorean identity for sine and cosine. Sine squared x plus cosine squared x equals 1. So let's write that down. So sine squared x plus cosine squared x equals 1. We know this is cosine, so let's fill that in. We don't know sine, that's what we're looking for. Cosine squared, so that's 1 over square root of 197, all squared. These problems really make you think critically about, what do I know, what do I need to know, how are those two things related? All right, let's go ahead and square this stuff right here. So square the top, square the bottom, and then we will move it over and figure out what sine is. All right, so I meant to write a plus there. 1 squared is 1. Square root of 197 squared, that cancels out the square roots, so that's just 197 in the bottom, equals 1. right, just move that 1 over 197 over. Cancels out right here. Sine squared x equals, you can think of this as being like 197 over 197. So you can, to get a common denominator, 197 minus 1 is 196. So that's 196 over 197. You could just do it in your calculator if you prefer to do it that way. Almost done. Let's see, if we're in quadrant 3, they told us that sine was going to be negative. And we need to go back and adjust cosine because of that too. But let's see, we're going to take the square root. Take the square root.
I get what you did with 196.
Okay, so I did right hand side right here. 1 minus 197. Excuse me, 1 minus 1 over 197. Convert that to a fraction. 196 over 197. So I just did this number here minus 1 over 197. So just getting sine squared x by itself. Does that make more sense? Okay. All right, I'm almost done. Got to cancel out my square root over here. That gives us sine of x equals, they told us that sine was negative because we're in quadrant 3. So that's negative 196 over 197. Negative square root of 196 over 197. All right, we're getting close. I need to go back and adjust cosine a little bit. I forgot to think about that, the fact that I was in quadrant 3. In quadrant 3, look on your unit circle. Is cosine negative or positive? Negative. So go back here and put a little negative on cosine because we're in quadrant 3. So that's important to remember. All right, so if you take care of that throughout the problem, you don't have to worry about it in the end. All right, so if you take care of whether things are negative or positive, you don't have to worry about that when you get to your final answer. All right. I'm going to have to do these two parts on a different piece of paper. So I went ahead and scratched them out. All right, let's do that a little bit. Here's what we've done so far. We figured out what quadrant we were in. We said, okay, the double angle formula for sine 2x is 2 times sine of x times cosine of x. So we need to know sine and we need to know cosine. We only knew tangent. So we went in and we used 2 of the Pythagorean identities to figure out what cosine and sine were. All right, so now we can go back to the beginning and actually use our double angle identity. All right, so all this up here was just sort of like scratch work so that we could find what we needed to know. All right, now we have 2 times sine of x. Sine of x is right here. It's negative square root of 196 over 197. And then cosine of x is negative 1 over square root of 197. You can simplify this more before we plug it in our calculator. For example, here you could split this up and do like square root of 196 over square root of 197. 196 is a perfect square, it's 14 squared. But if you have either one of the calculators, graphing calculator or this calculator, you can just plug this in and it's going to simplify it for you because these have the same denominator, so they're going to cancel the square roots out. All right, so, and that should happen for all of your problems. So regardless of, you know, what your original value is here, that should happen for this problem for all of you. All right, so let's plug this in. 2 times negative square root 196 over 197. Get out of the square root, close parentheses, open up parentheses again, negative square root 1. Well, let me be careful here. 1 over the square root of 197. close parentheses. I probably should have used my little fraction button. That would have made it look a little bit better. Convert this to a fraction is 28 over 197. Yeah, 28 over 197. So, yeah, when I was doing this, I was like, that can't be right. That is a super weird number. But that's actually correct. So it's just because you started off with a weird number, that 14 in the beginning. So don't be discouraged if you get weird numbers like this. All right, that's definitely the hardest one.
So that's the answer just for sine?
That's right, yeah, that was just for part A.
I got a question. You see what I said sine? Where you get that negative from?
Right here?
No, up more.
Right here. Yeah, good question. So the negative on the sine and on the cosine come from this part right here. In the beginning, they told us that tangent was positive and sine was negative. So we went to our unit circle and we said, okay, which quadrant do you have positive tangent and a negative sine? And that was in quadrant 3. Positive tangent, negative sine. So that means that sine and cosine both have to be negative. So that's where the negative comes from on cosine and on sine. Does that make sense? Yeah, so you got to be thinking about that after you solve for cosine and sine. So you got to think, okay, is this supposed to be positive or negative, depending on what quadrant you're in. All right, so that was just part A. The rest of them are easier though, because now we know sine and cosine. So this is really like the bulk of the work right here. Using the trig identities is not difficult. It's just plugging in numbers. It's the figuring out sine and cosine part that's hard. All right, so let's do part B and part C. All right, so part B was cosine of 2x. So go to your trig identity sheet. You can pick any of those 3 formulas to use, whatever one looks the simplest to you or easiest to use. I would say that this one is probably going to be the most difficult to use because it's got 2 things you have to plug in. I would go with one of these bottom 2, but your homework is going to show you how to do this using that first one. So if you want to, I can use that one, but I think it's easier to use one of these bottom 2. Are y'all okay with me using one of the bottom 2? Yeah. All right, let's just pick, let's see, which one did we do earlier? We did this middle one earlier, so let's do the bottom one. 1 minus 2 sine squared x. 1 minus 2 sine squared x. All right, we already know sine, so we'll just look back at our work. Sine was negative square root of 196 over 197. Right, so that's going to be 1 minus 2 times negative square root of 196 over 197 all squared. And again, you can just plug this in. Your calculator, regardless of if you have a graphing calculator or the TI-36. Let's see, 1 minus 2 times . Oh, it's not simplifying it for me. Do y'all getting the same thing? Decimals? Okay, so this one's not wanting to simplify for me, so we are going to have to do this one by hand. No big deal though. The squared and the square root are going to make this pretty easy to do by hand. So 1 minus 2 times, I'm just working on this exponent right now. So when you square this, you're just multiplying it by itself. So negative times a negative is going to become positive. And then we're going to have square root cancels with a square. All right, so that's going to become just 196 over 197. And again, negative times a negative is a positive. That's why the negative went away. Now let's go ahead and simplify. 2 times 196. We could probably do that part in our calculator. 2 times 196 over 197. Yeah, that's 392 over 197. The squared part? Okay. Okay. All right. 392 over 197. That's the 2 times part. And then we can do this part on our calculators, but I guess it was just too much for it to do all at one time. Yeah. Yeah, also, I feel similarly. All right, negative 195 over 197.
My calculator gave me that.
Did it?
Yeah.
Oh, okay.
I just have to type it in with the radicals on each of the individual.
Okay. So if you put a radical over the top, radical over the bottom, it worked. All right, so here do and that will give you the answer without having to do all this work. Okay, so we'll remember that for the next one. Oh, actually, the next one's going to be super easy because it's tangent. Tangent's going to be easy on this one because we were given tangent in the beginning. So tangent of 2x. So go to your identity sheet, look up the double angle formula for tangent. If you want to put parentheses around 2x, I think that's what the homework was doing, just to keep our notation the same. So the double angle formula for tangent is down here at the bottom. It's 2 times tangent of u over 1 minus tangent squared u. So we're going to use x's here. Now, like I said, this one's going to be pretty easy because we were given tangent in the beginning, and it was, remember, it was 14. In the original problem, it says given that tangent of x is equal to 14. So no, don't have to worry about like those crazy weird fractions on this one. So that's nice. So 2 times tangent of x was 14 over 1 minus tangent squared, so that's 14 squared. I think we can just type this in, should work fine. So that's 2 times 14 over, whoops, I cleared it out, 2 times 14 over 1 minus 14 squared. Yeah, negative 28 over 195.
Negative.
Do I plug it wrong?
Is it because of the like 1 minus?
Yeah. Yeah, it's from the denominator because this is 196, so 1 minus 196 is negative 195. Yeah. So that's where the negative comes from. All right, now let me look at this. I think that took us at least 15 minutes, right, to do those. So that would not be on the test. I can't have a problem that takes you 15 minutes. That's way too much time. I try to do it so that the problems take 5 minutes. So don't expect to see this on the test, but it does come up on the homework. And it's 3 parts.
Number 2.
Yes, all of number 2, A, B, and C. Yeah, because all the time was in the beginning. I think that alone took us over 5 minutes, probably. So, yeah, I don't see myself putting this on the test, but it is on the homework. I think the mastery level on this is 73%, so you could probably miss this and still master it. But like I said, this is the hardest one. So if you can do this, the rest of them should be easy.
Didn't you just figure it out like you did the following one?
Yes. Yeah, I tried with the triangle. And let me see, I have my work here where I did the triangle somewhere. Or maybe I didn't. I don't know. It's somewhere around here. I tried the triangle and I didn't feel like it was making it that much easier. So I decided to use the trig identities instead. But yes, you could totally do the triangle for this one as well. You just want to be careful and just remember like what quadrant you're in. So make sure that your, the legs of your triangle would be negative. let's see. I had one thing that I wanted to mention to you guys before we move on. But I can't think of it right now, so I'll try to be thinking about what I was going to mention. All right. From here on out, it's a lot easier. So if you're feeling a little discouraged, don't worry. From here on out, it's not as difficult as that one was. Some of the problems here are a little bit strange in that when you get to your final answer, it still looks like something that you need to keep going on. So you want to pay close attention to the directions and make sure that you're writing your answer in the correct form. You're probably not going to need to be plugging anything into the calculator as far as like, sine of pi or anything like that. So a lot of the answers here want you to just leave your answer in terms of sine. I remember what I was going to say. There is another way that you can do this that it might be easier, and it involves inverse trig functions. And I hate to even mention this because the point of this section is for you to use these trig identities, but I'll just show you really quick how you can do this like super fast on your calculator. If you know that tangent of x is equal to 14, you want to make sure you're in degree mode, and you would do inverse tangent of 14. That's going to tell you what your angle is. So that's the angle, that's what x is. And then you could just do sine of 2 times that angle and convert that to a fraction, and it gives you the answer. I know, wasn't that mean of me not to show y'all that first? I'm sorry. The whole point of doing this section is to learn the trig identities. So this is really like a sort of cheatsy way to do it. But I mean, it's not going to be on the test, and this is a really easy way to do it. So just FYI. If you missed that, it's on the recording, so you can go back and watch this part of the video to see how to do that. Okay, moving on. You can do that for every one of these problems though. Just so you know. But don't tell anyone I told you that, because that's not the point of this class. Alright. Anyway, moving on. Number 3. Like I was saying before, you have to pay close attention to the directions here to know how to write your answer. This one says, use appropriate identities to that's supposed to say rewrite, not require, to rewrite the following expression in terms containing only first powers of sine. All right, so you want to rewrite this so that there's only sines in your answer. Best way to do that is probably just to replace tangent with sine over cosine. You could try a different approach, like maybe you could replace this with sine over cosine. You could use a Pythagorean identity down here. Don't do that. It's easier just to use sines and cosines. All right, so using the fact that tangent x is sine x over cosine x, the top would become -4 times sine of x over cosine of x. Be careful, don't lose your x anywhere. Keep writing your x every time. Sometimes you get like in a hurry and the x will disappear. So keep writing your angle every time. And then we're going to replace this tangent squared with sine squared over cosine squared. So that's 1 plus sine squared x over cosine squared x. Probably a common mistake here is to try to keep change flip too early. Don't keep change flip yet. We're not ready to do that because we need our denominator to be one big fraction in order for us to keep change flip. So that's what we're working towards, but we need to get a common denominator in the bottom first. All right, so let's go ahead and just multiply the top. Ignore this bottom for a second. Just multiply numerators, multiply denominators up here. So that's going to be -4 sine x over cosine x in the top. That one's good. It's, a single fraction. We don't need to really do any work up there. Down here, we do need to get a common denominator. You can think about this as being 1 over 1. common denominator would be cosine squared x. So multiply times cosine squared x times cosine squared x. That's going to give us a common denominator. So it's going to be 1 times cosine squared x is just cosine squared x over cosine squared x plus sine squared x over cosine squared x. Again, we're doing all this so that we can get a common denominator in the bottom so that we can keep change flip. All right, now we have the same denominator down here, so just add the top, bottom stays the same. Negative 4 times sine x over cosine x. All right, add the top, bottom stays the same. So that's cosine squared x plus sine squared x all over that common denominator, cosine squared x. All right, let's just take a look at this for a second. Ignore this. All right, that's the Pythagorean identity. What does this equal? 1, yeah. So go ahead and replace that with 1. I really underestimated how long these problems would be because I did not give myself enough room. All right. I'm already getting messed up. All right, so negative 4 sine x over cosine x all over 1 over cosine squared x. Now you can keep change flip because we got a common denominator in the bottom. So go ahead and keep change flip. By the way, number 4 is taken off of the note, so you can use this whole space under here. So that's utilize that space. Keep change flip. That's going to be keep the top the same. Change the operation to multiplication, flip that bottom fraction. All right, we're getting close. Cosine in the bottom cancels with one of the cosines in the top, so that takes it down to just a regular cosine. So no longer cosine squared, it's just cosine x.
Wait, how did you get rid of cosine x in the first fraction?
Right here?
Yeah.
Yeah, so I'm canceling bottom with top here, or canceling diagonally, so one of these cosines cancels with one of those cosines. And then we have, I'm actually going to go this way. Sorry, these notes are so messy. I should have given myself more room. All right, that's negative 4 sine x cosine x. Nothing in the bottom. Denominator's gone. We're almost done, but think about what the directions said. Like you might, at this point, you think like, okay, I'm done simplifying. There's nothing else I can do. But the directions said to write your answer. So to use appropriate identities to rewrite the expression in terms containing only first powers of sine. So we don't want a cosine in our answer according to those directions. So we've got to do something to get rid of that cosine. So look at your identity sheet. Look for an identity that has sine times cosine. Look in the double angle section. Yes, the double angle for sine has a cosine times sine or sine times cosine. But we gotta have this 2 in front of it. So we can do some adjusting here so that we can use that identity. We could write this as 2 sine x cosine x. What do we need to fill in here to make this be the same? We want a negative 4 out here. Negative 2, good. Now you can go ahead and replace that 2 sine x cosine x with that double angle. So that's going to be negative 2 times sine of 2, our angle name is x. This is a first power of sine. This is a first power of sine. There's no squared anywhere. You don't have to worry about the fact that this is a double angle. That's not going to mess up your answer at all. This is how they want you to write it. So we've got a first power of sine. So now we can just stop, because that's our final answer. Something with a first power, where you only have first powers of sine.
Can you go over again how you got rid of the cosine?
Yes. So I said, okay, well, I need to rewrite this as 2 sine x cosine x, because that's my double angle formula. And then I just kind of ignored this for a second. And I said, all right, well, the formula for, or the identity for sine of 2x is 2 sine x cosine x. So this is 2 sine x cosine x. So that's sine of 2x. Does that make sense? Okay, so that whole thing is equal to sine of 2x. And then that negative 2 just drops down. We'll just write here double angle formula.
How did you turn a negative 4 into a negative 2?
Okay. Turning the negative 4 into a negative 2. I knew that I wanted to use my double angle identity because that was one where I had sine times cosine. And my only problem was this negative 4 in the front. I really needed a 2 in the front. So I said, okay, well, what would I need to multiply by to make 2 times something equal negative 4? And that's where the negative 2 comes in. So that way we're not changing anything. Negative 2 times 2 is still negative 4.
Okay, so 2 sine, and then what happens?
With the cosine. So this whole thing here, let me find my highlighter. This whole thing right here matches with this right here. So 2 sine x cosine x. 2 sine x cosine x. So
I got you.
that gets replaced with that. Okay. All right. Thank you so much for asking me questions, because sometimes, I don't know the part that is confusing to you. Let me see if I want to stop here, or if this is a good stopping place, or if we should continue on. I think we can stop here for today. We only have 5, 6, and 7 for Thursday, so I think that's we should have plenty of time to do those on Thursday. So let me stop the recording, and then I'll talk to y'all for a minute.